Hi, welcome to the Mind Factory. On this channel, we reproduce the latest results in artificial intelligence, deep learning, and robotics. In the last video, we reviewed a paper called Learning Fine-Grained Bimanual Manipulation with Low-Cost Hardware from the Robotics Department at Stanford University. In this video, we're going to review the WindowX and ViperX robotic arms from Trossen Robotics that were used to produce this result. So if that sounds interesting to you, give the video the thumbs up, consider subscribing, and let's get into the video. Okay, these are the two Dynamixel ViperX-300 6° of freedom arms. Power supply. Okay, let's go through the different joints on the robot arm. So we have the waist joint that rotates the arm. Then we have two Dynamixels driving the shoulder joint and two Dynamixels driving this elbow joint, like so. Right. Then for our end effector, we have this rotator. That rotates, and we have this hinge, and then finally another rotator for the end effector. Then a driver motor to open and close the end effector here. You can see it here. Okay, this is what's inside the plastic container. Allen keys, a neoprene pad, couple of plates, and a USB cable. So these are the WindowX-350 6DOF arms from Robotics. That's the base. There's the end effector.
Yeah, let's take a look at the data sheets for the robotic arms. So what we're using is the X series arms, and we'll just take a look through the ViperX-300 6DOF arm. That is the follower arm and the main arm that's performing tasks. This is a summary of the arm. It's a 6DOF arm, about 750 millimeters of effective reach. Repeatability of 1 millimeter, not a super precise arm, accuracy 5 to 8 millimeters. So to do delicate tasks on this, you really are going to need to use closed loop control. We're also provided with the product of exponentials matrix for this. So we've got the home position matrix, and we've got the Jacobian matrix. So if we want to write our own kinematic models to control this arm, those settings are provided. In addition, you can see the joints here and how they're set up. So they give us the servo type for each joint. So if we blow a servo, we can order replacement servos. These are the Dynamixel servos. So there's the XM540, right? And we've got this guy here, the XM430. So these are the two types of servos And mostly it's using the 540 servos, except for the wrist and the gripper where it uses the smaller servo. Okay, so if we look at the sort of bigger servo, this is the spec sheet for it. Taking a look at the servo, they're sort of entry-level robotics grade servos. The main features I find interesting on this servo is the data bus can be daisy chained. So you can have like a single data bus that connects a bunch of these servos together. Also, they operate in dual mode and the robot arm uses that. So there's a couple of the elbow joint and the shoulder joint are in a dual configuration. So there's two motors, so you get a bit more power out of that configuration. Each servo has a pretty sophisticated controller built into the motor. Okay, the controller on the Dynamixel is pretty sophisticated. There's position controller that has an inbuilt PID control circuit. The gears have encoders so you can get an accurate position. And it looks like the encoder has about 496 ticks for a full revolution. Probably the best thing about this arm though is that it comes with software. So there is a ROS1 and ROS2 interface that you can use. And so you're given a bunch of software packages. There's an SDK that comes with it. There's a bunch of tools. And so here you can go to GitHub and you can see that they have a software package that creates a bunch of ROS topics, and you can control the joints, you can change the operating modes, you can change the PID gains. In addition, they include models of the arm, so you can get it running in Gazebo. So you can work with this arm in simulation, and they also have URDF descriptions for these arms as well. And in addition, if you want to use it, it looks like we also have some inverse kinematics libraries. It looks like you can set the end effector position and it will figure out the joint positions for you. Although we're not going to use this in this project.
So that's a look at the robotic arms that we're going to use to reproduce this paper. In the next video, I'm going to go through all the parts that I used to reproduce this result. So if that sounds interesting to you, I'll see you in the future.